Hello everyone, I am Dr. Lalitha, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. So today we are going to discuss about the topic resistor color coding. So what is a resistor? Why we are going to find out the color coding of the resistor? What is the necessity of finding the color coding of the resistor? All those we are going to see in this video. So first, what is a resistor? So resistor is a device which have the property of resistance. What is a resistance? Resistance have the property of opposition of flow of electrons through it. So a resistor is a two-terminal device which is having a very important component, which is a very much important component in building any electrical circuit. Any electrical and electronic circuit, resistors play a major role. So why we are going for color coding? So why they will give the color coding for the resistors? So all those we will see. So first, resistor is a component which is used to limit the flow of electrons, means which are going to restrict the flow of electrons through it so that regulation of flow of electric current will take place. So we commonly see the resistors in different colors. So what is the purpose of having the resistors in different colors? Means, see, in general resistors are very much small. So we can't print the values of resistors on the resistor itself. So that's why what they had done was, they had given the color coding for the resistor. So based upon that color coding, we are going to determine the value of the resistor. Generally, it usually contains of 4 bands of colors. So in order to know about the value of resistors, so we have to calculate the resistor color coding. So as we know that the resistors are very small and very much tiny, and it is very difficult in order to print the value of resistors in the particular resistor. So that's why the color bands will be printed on them in order to represent the electrical resistance. These color bands are called as color codes. So this resistor color coding was invented by Radio Manufacturers Association in 1920. So all main resistors up to 1 watt are marked with these color bands. So there are many bands which are connected together which specify the resistance value, tolerance value, and sometimes the reliability or failure rates of the particular resistor. So the number of bands which are present in the resistors can be varied. Means it won't be fixed up to 4 bands or 3 bands like that. It may be varied from 3 bands to 6 bands. It may be 3 or 4 or 5 or 6. So based upon that, how many bands are there? We have to calculate the value of resistors based upon those bands. So in those bands, the first 2 bands indicate the resistance value. The third band indicates the multiplier, and the last band indicates the tolerance value of the resistance. So this is the color coding chart of the resistor. So how we can easily remember this one was, so see the colors first. So black, brown, red, orange, yellow, green, blue, violet, grey, white, gold and silver. So we can easily remember the gold and silver. So these are nothing but the tolerance values. So first see up to here to here, means black, brown, red, orange, yellow, green, blue, violet, grey and white. So we can easily remember this as, see, first consider the first letters of this colors. First letters. So what is the first letter? B. What is the second letter? Brown. What is the third letter? Red. Fourth letter? Orange. Fifth letter? Yellow. Sixth letter? G. Green. Blue. Violet. Grey. And white. So now you can remember this very easily as B. Roy, Great Britain, very good wife. B. Roy, Great Britain, very good wife. Means in order to remember the color values, just I was telling the easy way in order to remember these particular values according to the multiplier and tolerance. So according to this, see, B means black, B means brown, R means red, O means orange, Y means yellow, G means green, B means blue, V means violet, G means grey, W means white. So according to this, you write the values of the digits from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. From 0 to 9, you write down the values of the digits. Okay. So next one, coming to the multipliers. So in the multipliers, in the first one, you write down the value of 1, 10, 100. You are increasing the 0 terms. 0, 100, 1000. So 10,000. Likewise, you are going to increase the values and don't write the values for the grey and white. For the grey and white, you don't write any values. Up to violet only, you write the values. So for this, for the gold and silver, the tolerance and multiplier value will be there. So the multiplier value for gold is 0.1 and the multiplier value for silver is 0.01. So up to here, the color values and the digit values and the multiplier values we had reminded. So now we will see the tolerance values. So this tolerance value we have to remember for each color. So for brown, it is plus or minus 1%. For red, it is plus or minus 2%. For green, it is plus or minus 0.5%. For blue, it is plus or minus 0.25%. For violet, it is plus or minus 0.1%. And mainly the important are gold and silver. So in 99% of resistors, gold and silver values only will be there in the tolerance. So remembering of these two values is very much important. So plus or minus 5% for gold and plus or minus 10% for silver. So if we prepare or if we learn this chart completely, then only we can find out the color coding of the resistor or we can find out the value of the resistor. So based upon this color and based upon the value of digits, multipliers and tolerance only, we can able to find out the value of the resistor. So first we are determining the colors. So we are remembering the colors by these terms. B. Roy, Great Britain, very good wife. So according to that, we are writing down the colors. We are writing down the colors in the order. So after writing all these colors, gold and silver will be there. Okay, gold and silver will be there. So according to this, according to the digits means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Linely you are writing down the numbers. After that, we are going to writing down the multiplier values by increasing the 0 terms here up to violet. For grey and white, no multiplier values will be there. Similarly, for the tolerance we have to learn the tolerance values. For brown is plus or minus 1%, for red is plus or minus 2%, for green is plus or minus 0.5%, for blue is plus or minus 0.25%, for violet is plus or minus 0.1%, and the main important one was gold and silver. For gold and silver, it will be plus or minus 5% or plus or minus 10%. So these are very much important. So likewise, we are going to remember the color coding of the resistors. So now based upon this color coding, we are going to find out the value of the resistor. Okay. So how we are going to find out the value of the resistor? In further slides, we are going to see. So how to read a color code? So by seeing the colors, how we can determine the value of the resistor? In order to read them or in order to find out the value of the resistor, first of all, what you have to do means we have to hold the resistor. Okay, hold the resistor such that the tolerance band will be there in your right. Tolerance band. So this one means either gold or silver should be there. Either gold or silver should be there. So hold it like this. This gold or silver value will be there this side. Likewise, for right side of the resistor, your tolerance band, either gold or silver values will be there. Likewise, you hold it. So the tolerance value is generally 99% it will be gold or silver only, and it will be a little bit apart from other colors. So remaining, suppose it is a 6-band resistor, 4 bands will be in one order, and after some space this gold or silver will be placed on the resistor. So we can easily identify this band, means this tolerance band we can easily identify. It will be in gold or silver color, or by seeing that we can identify, or it is having some space in between the normal bands. By seeing this also we can identify that. Okay, by using these two we can identify easily about the tolerance band. So starting this side is the tolerance band. So now from this side, starting from the left, we have to note down the color values. Means here bands will be there, no remaining bands, what are the colors will be there. You note down the colors of the all bands and write down in a sequence. Write down in a particular sequence. So now by using, how we are going to write down in a sequence? By seeing the color coding in the resistor. So in the previous slide, as we had discussed about the color coding, so in that, according to this color, what is the number is there, you note down it properly. So based upon that only, we can going to find out the value of resistor. So the band next to the tolerance band is multiplier band. So here these two bands are color bands. After that one was multiplier band. After that one means the last one was the tolerance band. Last one was the tolerance band. So now we will see how many bands will be there. If how many bands are there, how we can going to calculate the resistance value, we are going to see. So see here. So in this resistor, see what I had told, right side we have to consider, means whether it is a gold color or silver color, tolerance band, it will be there, consider it from the right. So this is a tolerance band. See this, these three are nearer and this here space is little bit different when compared to these two spaces. So that's what I had said previously. So this space will be somewhat far when compared to these two. So from this also we can determine the tolerance value. So this one is tolerance. Before the tolerance one was multiplier. So this is multiplier. This is the second digit and this is the first digit of the resistor. So now see, B. Roy, Great Britain, very good wife. B. Roy, Great Britain, very good wife. So in this first digit, second digit, multiplier and tolerance. So what is the value here? First digit means what is the values which we had taken from this table here? See 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So similarly here also we will write the same 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly for the second digit also, it is not multiplier or it is not tolerance. So for any number of digits, we are going to write down the values like this only. Even we are having here another band also. For third digit, we'll write and we'll write down the values like this only from 0 to 9. So here in the first digit, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For this, for yellow. Next one was for this. What is for this? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Next one, the third one was multiplier. And the last one was tolerance. The what is the multiplier values? So 1, 10, 100, 1000. So likewise from the table we are going to fill these values. For gold it is plus or minus 5%. For silver it is plus or minus 10%. All these values I got from the previous table which I had explained only. But here just I was showing to represent very easily to understand. For understanding purpose, I am representing separately here. The same values are there in the table also. So no need to confuse. So according to this, see here. So first term, what is the first one? Yellow. For yellow, what is the number here? 4. 4. So I had written the 4. For the second digit, what is the second digit here? Violet. So for violet, what is the value here? 7. So 7. 4, 7. Next, multiplier. Multiplier means we are multiplying here. Okay, multiplying. So for this red, for red what is the value here? 100. So into 100. Okay. Next last one was tolerance. The tolerance for gold color. Here gold color is there. So I am taking as gold color. So for gold color, the value is plus or minus 5%. So the value is plus or minus 5%. So if we are writing down all these values, see 4, 7 into 100 means 4700 ohms plus or minus 5% is the tolerance. So this is the value of resistance. This is the value of resistance. So if they had changed the colors here also, the same procedure. The same procedure will be there. So here for example, red is there or orange is there. This is multiplier and this is tolerance. Okay. So for red, what is the value here? 2. Right. So the value will be 2. Next, orange. So for orange, what is the value here? 3. 3. Okay. This is the first digit. This is the second digit. Multiplier. So what is the multiplier? Red. So into 100. What is the tolerance here? Plus or minus 5%. Or otherwise you take here, for example, silver. So the tolerance will be plus or minus 10%. So what will be the value of this resistance? 2300 plus or minus 10%. So this is the value of this resistor. This is the value of this resistor. So likewise, we are going to find out the value of the resistors by using this color coding in the which is printed on that resistor. So here we are going to see a problem. So see here red is there, black is there, and tolerance is there. So this is the tolerance value, this is the tolerance, this is the multiplier, this is the second digit and this is the first digit. So first digit means red. So what is the value of red? See here 2. Value of red is 2. So 2. Next one, second one also red. So the value is 2. Next, multiplier means into 1. What is the value of tolerance? Plus or minus 5% because gold is there here. So the value of resistance is 22 ohms plus or minus 5%. 22 ohms plus or minus 5% is the answer for this resistor color coding. So what is the tolerance? What is this values? What is this multiplier? What is this tolerance means? The tolerance values represents how much the resistance can vary from its mean value in terms of percentage. Means everything can't be fixed. That resistor also have some particular value, how much amount of current it can withstand. So how much it can tolerate. Okay, if the value of this resistance can be tolerated up to plus or minus 5%. So by seeing this, we can determine the tolerance of the value. So gold band represents the lowest variation. So be sure so that we can buy very easily in the electronics store. Okay, so for that sake, we are going to represent the tolerance value also. So finally, we are going to determine the color coding of the resistors by using the chart of B.B. Roy, Great Britain, very good wife. Unless or until you had learned about that table, you can't determine the value of color coding of the resistor. Okay, thank you.